So, going over these three properties, the commutative, associative, and distributive properties, there are two versions of the commutative property. And by the way, let's learn to spell these. It's not the commutative, it's the commutative. Like commute means move. Your parents, they commute to work. That means they drive to work. They change where they are from one place to another. A commune, if I said commune, that's a place where people used to go in the 60s when they were hippies and smoke funny cigarettes and do things like that, all right, and wear lots of beads and have long hair. That's a commune, all right? This is a commute. You're commuting. Property, remember, that's a truth of mathematics, and this is the property of addition. What this property says is that order doesn't matter when only adding, and this will come into play a lot when we get into some algebra. So the result will stay the same. So what is 5 plus -3 plus 6 plus -2? What does that actually equal? And then we'll show that if we change the order, it won't matter. Okay, so what does that all equal? Hello? So it's 2 plus 6, right? So that's 8. 8 plus -2. I'm getting 6. Right? So it's 6, right? Now, if I change the order, do it any way you want. I'm going to say 6 plus 5 plus -2 plus -3. Do I get any? And a lot of times that's what people do. They'll put the negatives together and the positives. Does anything change here? No. So that's the only point of that. Sometimes it will be to your advantage to move things around, either to make the arithmetic easier, or to, when we get to algebra, put like terms together. So there'll be reasons why we do this sometimes, all right? Trust me that this is not the most exciting thing we'll ever discuss this year, but it is very, very important. Now, before we go on to do the other version of the commutative property, we're going to talk about the associative property of addition. Now, the associative property of addition is, first of all, let's think about what the word associate means. That means to get together with other people. If I associate with my friends, that means I get together with them, I group with them. So whereas the first property is about changing the order, this property is about changing the grouping, all right? So grouping doesn't matter when only adding. Now somehow I lost my example here. That's all right, I'll just make one up. So the grouping doesn't matter. Now notice the change in the words here. Grouping now doesn't matter. And then let's say the sum will not change. So I'm going to go with 5 plus -3 plus 9. All right, now let's say right now that this is grouped as such. All right, that would mean I have to do what first? If I put those parentheses around the 5 plus -3, I've got to do that first, right? So that would be what? So that would be 2 plus 9, and I'll get 11. Now, to just show this property, to just demonstrate the property, I'm going to change the grouping. This time, now I'm not going to change the order of the numbers. Notice the order of the numbers will not change. But this time I'm going to change the grouping. Now this time, those red parentheses mean, what do I have to do first? I have to do the -3 plus 9. What does that equal? Now notice I still got 11. Is that clear what that means? Now, just before we go on to the next properties, I want to just show you, now there is no commutative property of subtraction, right? So if I say, for example, if I say 7 minus 3, what does that equal?
4.
Notice I don't get the same when I change the order. This time I get -4. So there is no commutative property of subtraction. There's also no associative property of addition. I'm sorry, of subtraction, because you will get a different result. Oh yeah, definitely multiplication. We'll get there. So if I change the grouping with subtraction, let me just show you why it doesn't work. If I go, let me go 8 minus 3 minus 10. So what does that all equal? Well, let me put some grouping in here. So what does that equal when I go 8 minus 3 minus 10? That equals -5, right? Now, let me change the grouping. All right, now I'm going to say, now this time I do what? I go 3 minus 10, so it's 8 minus -7, I get 15. So there is no commutative property of subtraction. All right, let's go to the next page. All right, now commutative property of multiplication. So you got to get all this down. Listen, if you're not getting this down, it won't be there for you. Remember, this is a non-textbook course. Your notes are your lifeline. If it's not down, you really don't have a place to have this. Now, I do record all these. You can go back and fill it in later. But if you're going to do this just because, oh, it's uncomfortable, right? You got to get everything down. So, so the next version of the commutative property, and the only other version of the commutative property, is going to say that that order is not going to matter when only multiplying. Oh shoot, there's a typo there. Oh, will result in the same product. No, that's right. So the product won't change if I change the order. So in this first example, what is in this example right here, what is the result if I multiply these numbers together? What's the result? Okay. Now let's change the order any way we want. It's positive, right? Two even signs, right? I mean, two negative signs make positive.
Oh, yeah.
So I'm going to change the order. Times, what am I missing here? 5, right? So notice I still get 100. Okay? All right.
Every multiplication problem.
That's the commutative property of multiplication. All right. There is no commutative property of division. Division, you can't change the order and get the same thing. 10 divided by 5 is not the same thing as 5 divided by 10. But you can change the order with multiplication. Okay. Associative property of multiplication, the grouping the grouping will not change. Shoot, that doesn't make sense what I have there. The grouping will not change the result, I should say there, when only multiplying. Okay? That needs to, I left out a couple of words there. The grouping will not change the result when only multiplying, will result in the same product. So I haven't grouped this expression yet, right? I'm going to group it now. So I'm going to make the grouping like that. So that would say I have to do what first?
5 times -8 times 3.
Yeah, I got to do that first, the parentheses. So what is -10 times 3? So that's -30 times -1 times 10. So all of that equals what? 300. Now let me rewrite the expression without changing the order of any of the numbers. Does everybody notice I'm not changing the order of the numbers? That would be commutative property. But this time, I'm going to change the grouping. I'm going to group these three first. Got that? Now it says I have to do what first?
3 times negative 1.
3 times negative 1 times 10, and what's that equal?
Times 10, which is negative
That's negative 30. And if I multiply that by 5 times negative 20, negative 2 times, I'm still going to get, so that's negative 10 times negative 30, I still get 300. With me? Getting it down, making sure your notes are thorough so you look back on that, it's all there for you. Okay, so last page, the last two properties we have to talk about is distributive property of multiplication over addition. And that's a lot, it's a mouthful of words. When they ask you to write the property out, you got to write it out with the operations in mind. So really the way I'd explain this is under certain circumstances, violating strict order of operations is permissible. All right, so let me show you what I mean by that. So when you have a number that's up against parentheses with a sum inside, right? What would order of operations tell us to do here?
parentheses first.
It would tell us to do what?
The parentheses first.
It would tell us to do the parentheses first. So we go 15 times what?
10 plus 2.
Times 12, which is equal to what? Does anybody know what that equals? That's 180.
180.
Now, yes, sir.
The distributive property is when you multiply 15 times 10 or 15 times 2, right?
Right, and I'm going to sum those. So the distributive property says I can multiply this 15 by the 10 and then add to that the 15 times the 2. All right? And I'll get the same thing. Now again, this becomes a very handy property because sometimes you'll have what are called non-like terms in the parentheses, so you can't add them. So the only thing you can do to simplify the expression is use the distributive property. So this will really come into play in algebra. So what this property says is I'm not going to do the inside of the parentheses first. I'm going to multiply the 15 by the 10 and then add to that the 15 times the 2.
150 plus 30,
And so I get 150 plus 30,
which is 180.
and I get the same thing. So you have to know when you can apply this property. When you have a number, so what do you think distribute means? Distribute means give the 15 to the 10 and give the 15 to the 2. That's what distribute means. When it says multiplication over addition, it says we're going to do multiplying before we add. Order of operations would tell us to add first there, right? But we're going to do it another way because we can. And if we get the same answer all the time, then it's okay to do that. We have to know when we can violate order of operations. It's this scenario where that's okay.
Does that work with division?
Actually, yes, it would. All right, yes, it would. We're not going to do that now. Good, very good question. It would work. When it doesn't work is when you skip a whole level of operations. For example, you can't distribute exponentiation with addition. All right, but you can distribute division with addition and subtraction. Yes, very good question. I'm not going to make you responsible for that just yet, but very good question. All right, so let's scroll up here. Last one, last property we have to learn. Very, very similar. Distributive property of multiplication over subtraction. I missed a C in there.
Say it again.
Anybody see the missing C there? That's not how you spell subtraction. Stick a C in there, right? Between the A and the T, right? So what do you think that, what order of operations tell us to do here? Yes, Noah?
But it tells you to do 10 minus 2.
So we go 15, this time 15 times 8, right?
Which is 120.
So that's 120. Now if I use the distributive property,
15 times 10,
15 times 10 minus 15 times 2.
Which is 120.
150 minus 30, I still get 120. All right? So Your homework tonight, so let me stop this.